Welcome to AlexGs Aquarium, everybody. Today we're going to be talking about a different topic, something I haven't talked about before, and that is aquarium heaters. Now, aquarium heaters are an essential device for most aquarists, not all. But in my case, I have 1,600 gallons of water. I'm going to have to heat it up. Probably going to keep it around 76 degrees. And a heater is typically what you use. In this case, I got a glass 500 and I got a titanium 500 watt. And these are really good devices for heating up aquariums. But they're also a device that can cause a lot of pain and sorrow and emotion for aquarists. And this is for freshwater, saltwater, everybody. I've never had a heater failure in my 20 plus years of experience in keeping aquariums, but I've read enough stories on forums like Reef to Reef about heater failures causing the death of some, if not all, of their tank, either through metal poisoning, through electric shock, or through metals leaching into the tank. And every time I read one of those stories, I get really shaken up by it, because I know the feeling of losing something, and to lose something to a device that's critical to a tank, yet something that can do so much destruction in a little amount of time, really makes me nervous. And I think the one that probably hit me the hardest was probably watching Joey the DIY King and his incident with heaters, which ended up killing his stingrays. And you know, at that point I was really starting to take a long hard look at how I was going to heat this 1,600 gallon system. And I ultimately decided I'm not doing it. I am not using glass heaters, titanium heaters, or any kind of heaters like that in this 1,600 gallon tank. I'm not doing it. And I looked around for a while to try and see if there were other solutions out there. I even thought up some things myself. But I ended up finding somebody on Monster Fish Keepers that did something that I had heard about it being done with large size tanks, but never actually seen it done or seen any kind of instructions on how to do it. And that's why I purchased this pump, which I unboxed a while back, this bronze recirculator pump. Now, instead of using those electric heaters, I'm not going to use electric heaters in any way, shape, or form. Instead, I'm going to use gas. And I'm going to use my hot water tank in my home to heat this tank. I've never done this before. I've honestly never known anyone that's done this before, at least somebody, personal, that has been able to say, hey, this works. But I like the design. I do not take credit for this design at all. Let me get that straight out to the point. I got this from vldesign.com. He's on Monster Fish Keepers. I'm going to post a link to the forum threads that are on for this, and I'm also going to post the PDFs that I got from his website that he had for download. I'll post links to those as well so that you can see how this is done. Now, one thing his design does lack, or his instructions lack rather, is more of a how-to. And I figure since I'm trying this out, I'm going to share this with everybody because I think it's a really good idea and I really want to see this work. So the principle is that you're going to use your hot water tank from your home to heat this tank, or your tank I should say. In my case, I got 1,600 gallons of water to heat up. We can use the hot water from the hot water tank very simply by tapping off the line, bringing it to the aquarium. The challenge becomes is how do you recirculate water, because we're not going to just spill it out onto the floor or dump it into the tank, because that wouldn't make sense. We have to be able to do a closed loop of hot water through this tank, which this 120 is going to be used for the heat exchanging tank, in order to take the heat from the hot water tank and pass that heat into the system. So of course we're going to need something that's saltwater safe, and to do that we're going to use plastic plumbing pretty much everywhere I can in this. There's going to be a couple places where I still use copper. Now this 1/2 inch bronze pump was chosen for a very specific reason. And I will point out, and one of the links I have for the PDF that talks about how to do this, the original pump that they used was a cast iron pump. And in reading in the forum posts about it, and I have put a link to that in the description below as well. Someone else had kind of challenged the original design that VLDesign.com used in stating you can't use a cast iron pump in this type of situation because it will start to corrode and rust because it's not a closed system, and that's all cast iron pumps are designed for. Now I know you might think, well, it's a hot water tank, you're going to take water out of it on one end and we're going to put water back into it on the other end. That could be considered closed, but technically that's an open system because there's new water coming into the hot water tank and water leaving the hot water tank. So that's why I switched up to a bronze pump. And actually, when you read the forum posts on this, VLDesign.com, the gentleman that did this, he also, discovered that his cast iron pump had a lot of rust and corrosion in it. So he changed it out to a bronze pump. That's why I went with bronze. You could either do 3/4 or 1/2 inch. I chose to just go with 1/2 inch fittings on everything. They do sell these with flange kits and stuff on them, but since I went with 1/2 inch, I have sweated fittings on the ends here. So that's going to be one of the very first things that we tackle with this build, is we're going to take the whole pump housing here, we're going to take that off, and we're going to clean it up, cut out a little bit of copper, and then I got 2 male threaded ends to sweat on here. So we're going to go out, get the torch going, get that soldered up, and then we're going to go through this whole thing step by step. This is going to be a multi-part video series. I want to go through all the details of it. Once we have this whole thing assembled and working, I'm going to show you how it gets controlled. Because obviously you can't just have this pump come in here and start pumping hot water into your tank because it's going to overheat it quickly. This is what the Renko controller is for that I also unboxed. The Renko single stage controller is similar to just about any kind of aquarium controller like an Apex. This is just an industrial temperature controller. Essentially what it does is you set your temperature in here, it'll energize something in order to make it work. In this case, this recirculation pump will start kicking on and pumping hot water in when this makes a call and says the temperature's too low. Now I know there's going to definitely be some tweaking with this and everything because I have a long distance for this water to travel. So I have to really kind of tweak this temperature controller and determine at what temperature should this really turn on and off, because there's going to be a bit of a temperature lag, as I would call it. By the time the water exits the heating coil here and gets into the displays, the water has to go through the displays and come back through all this filtration and back to this temperature probe wherever I decide to put it. So I'm going to be playing with this for a little while to get it exactly where I want it, to where I know I don't have a chance of overheating my tanks. And we're going to start with a single stage controller. I might go to a dual stage controller eventually as well, or I might kick in other controllers on top of this. I might integrate an Apex into this as a double temperature redundancy. But these Renko controllers are very well trusted as an industrial temperature controller, and that's why I made this purchase. This is also what VLDesign.com was using when they designed this system and installed it on their large freshwater system. So let's go in and get these fittings sweated on. I'm going to show you guys how I did that, and we'll start walking through the rest of it. So let's go into the garage, get these fittings sweated on. Now that we're in the garage, we can go ahead and start working on sweating these fittings on. First, I need to remove this pump housing, so let me go ahead and do that. I've already pre-loosened some of these here. Alright, we got that off. So you can see there's just a little impeller in here, and then it's got its own little rubber seal. This you don't want to expose to the heat of the torch because it's going to melt and ruin this pump. Don't want to lose those screws. Now I've already gone ahead, I got this piece off, and I just double checked it here real quick. It's all bronze, there's nothing rubber or plastic in it. Anytime you're going to do soldering, sweating fittings, you always want to make sure that you don't have anything on there that is going to come back to get you, such as plastic, rubber O-rings. It's never happened to me, but I've seen it happen, and it can be quite hilarious in its own right. Now bronze does take a little bit more heat to get going. I did have a big acetylene torch I was going to use for this, but it's out of gas. I ended up getting a MAP gas torch. Now matte gas is a higher temperature. It'll help heat this up a little bit more. If you haven't done sweating on copper, brass, bronze fittings before, well, you're going to get a small lesson in it. Now, I will admit I am not a professional at this. I know how to do it. My solder joints look ugly, but they don't leak. I'm just putting that out there right now. Now, first thing you got to do for all of your copper fittings here, we have to have our solder. So we have that now. You need to have a cleaning brush. You need to have flux and all your fittings. Anything that's got an inside fitting, we're going to hit with the inside of the brush. Get it nice and cleaned up, roughed up a little bit. Do that to the inside of every fitting. Also, the outsides of everything need to be done. I'll show that here in a second. Goes on, and then the ends also go on these little two-way brushes. I'm going to clean the ends of the copper as well. You want to try and keep this all as clean as you can. And then I'm going to go ahead and put flux on everything after I just give it another wipe down. And then we'll go ahead and get started on the actual sweating process. And we got that done. Go ahead. Get the flammable liquids away from the torch. Let this dry out for a couple of minutes. I've let all the fittings dry for a couple of minutes just to make sure that don't have any excess alcohol on here. Now I'm going to go through and I'm just going to apply flux to all the joints. With the flux on all of the pieces now, I've just kind of pushed it all together and assembled it. When you're sweating joints together, you really aren't going to be holding it in any way most of the time, because it's going to get really, really hot. Matter of fact, it's going to get several hundred degrees hot. This piece of bronze here is going to take a little bit of time to heat up in order to allow the solder to go into the fittings. And the way solder kind of works is with the flux on here and in the joint, when you heat it up, all I simply do is touch the solder on there and it'll get sucked into that fitting. Now, there's probably going to be a few drips and stuff, and that's okay. Like I said, I don't do this very cleanly, but I could say that they don't leak. So I'm going to start with the big piece here, and you can't just heat all of it in one spot, because if you do, you could cause thermal damage to this, and it could warp or break, and we don't want that. We only want to heat it up in order to do the soldering, but we want to heat it fairly evenly too, so that we don't damage the piece. So I'm going to be kind of running the torch all over it to get that. And I ideally probably would want to keep this elevated like this, but I'm going to flip it down here, and we're just going to run the torch around it. The copper fittings on the end here, we'll see how those heat up first. I might touch those with the solder first. And then once we have that done, then we'll be good to get this soldered up. We'll let it cool off. We'll have to get it all put together, and then we'll test it out and find out if it's actually going to hold. So let's go ahead and get started. Oh, one last thing. Make sure whatever you're going to do this on is something that isn't going to be flammable. I know this is a piece of 2x6 here, but it's been soaked in water for about 30 minutes. I also have a fire extinguisher here, which anytime you're playing around with torches, make sure you have a fire extinguisher handy. That could be something that could potentially save your home and your life. So let's go ahead and get started again. Well, there you have it. Another thing is, when this is getting a little smoke off, don't breathe it in. I've been holding my breath when I go over the top of this. Now let's see how hot this thing really got. So I just checked this thing out on a thermal imager, and it's over 500 degrees right now. So we're going to have to let this sit for a while before I try to touch it. I'm going to let it cool off naturally. Not going to quench it. Not going to try and cool it off at all. Just let it cool down on its own. I'm going to just quickly go over with everybody here the brief layout of this heat loop. I think it's important to just do this step. I just briefly wrote it down on a piece of cardboard. You probably can't read it all, but I'm going to walk you through this step by step. This is the start of this heat loop. Now you have your hot water tank, and out of the top of your hot water tank, you're going to have supply lines running out. Now I have a supply line that is going to my washing machine. The washing machine line, I don't want to interrupt it and stop it from going to the washing machine, but what I'm going to do is I'm going to cut into it, break into it, and put a T-fitting in, and then I'm going to tap off of that T-fitting and go to a shut-off valve. This will allow me to control the supply line for my heat pump. Off of this supply shut-off valve, the next thing I'm going to do, just for safety's sake, is install a check valve. Now this check valve is just going to serve the purpose to make sure that somehow hot water doesn't backfeed into this loop from the drain side. That's all its purpose is. Whether or not it actually becomes useful, I really won't know unless I start to monitor it. But I wanted to put it in as a safety device because I don't want to allow backfeeding into this loop. And I would recommend that anybody that's going to do this should at least at a minimum have this type of check valve installed. Next, I'm going to go from one of my compression fittings into a female threaded connector, which then goes into our pump. The pump, of course, is going to have water getting driven through it, which this is what should be controlling the water flowing through the coil. It shouldn't have water flow without the pump on, which is something that once I get this installed is going to be important for me to monitor and determine if I need to have a secondary safety device installed, which I'll discuss a little later on here once we get this whole thing installed. From the pump, it's again going to go into another female threaded into a compression fitting. And then we're going to go into the heat exchanger, which is going to sit in the 120 gallon sump. This heat exchanger is what's going to be heating the tanks for me. After we exit the tanks off of the heat exchanger, I'm going to go back to the hot water tank. This line here that comes out of the sump and back, and even the supply line potentially, I'm going to insulate just so that I don't get heat loss just into my basement, and that way I'm being more efficient about using the hot water. I'll then go through another shut-off valve, which is going to be located right by the hot water tank. And then I've got to connect back to the hot water tank, which I have to say, when I first was looking at doing this, I didn't quite understand how to hook back up to the water tank. But this makes perfect sense. This T basically connects on from right here, which is a female hose thread, into a male pipe thread. I then go into a T and I put another boiler cock valve on here that allows me to still have my emergency drain for my hot water heater. You should not compromise this. It needs to stay here. It's an important thing to have on your hot water tank in case it ever needs to be drained. And then I have basically my return coming in here. So once I get this all hooked up, the existing valve that's on the hot water heater, I'm going to open it up so that it allows water to freely flow back into the hot water tank. And this is the whole loop. So it's going to be it's actually a really simple thing to do. It just needs a few plumbing parts. The one thing that you got to look at here is how are you going to use a heat exchanger. Given this loop is all made out of copper, brass, and bronze fittings, obviously we can't have them in contact with the salt water. One, it's going to cause corrosion, and two, it's also poisonous to most of the animals I plan to keep in these aquariums, which is not a good combination. There is a solution though. PEX plumbing. It's a plastic plumbing. It is aquarium safe. What we are going to do is we're going to use the PEX pretty much for the entire run of this. As soon as I tap off of my supply line, I'm going to go into PEX. And the only places where PEX is not going to be present is where all these fittings occur in the actual pump. As soon as we get out of here, we're going to go ahead and go to PEX. And I'm going to have to make some kind of heat exchanger, which that might be its own video, we'll see. This stuff doesn't wrap super tight in a coil. It can coil up to a decent diameter, but it's something I'll have to play around with and see what's going to work. And once I get a heat exchanger design, The big thing is going to be is how big of a heat exchanger do I want so that I don't overheat the tank. I'm then going to just run this right on back to the hot water tank and PEX as well. I bought all these shark bite connections, which I know they're a little bit more expensive, but considering that if I ever have to remove this, it's going to be a heck of a lot easier to remove this type of stuff rather than something that I'm soldering a bunch of fittings on. And quite frankly, even my supply line is right next to the gas line that's for my dryer. I don't want to use a torch by that. So we're going to use compression fittings, keep it simple. All you need is a pipe cutter then just to tap in, take a section out, go ahead and put the compression fittings in. And then I have shut-off valves for the supply and the return, so I can isolate if needed. And worst case, if it comes down to it and I have to take a section of this out, or in another scenario add a section to do more heating, I could always cut it and use more compression fittings to do that. This is the whole heating system loop. I'm going to go ahead and start the installation. Once we get this all installed, we're going to walk through it one piece at a time. We're going to do a number of videos on this. Once we get it installed, I'll probably do a little initial testing just to make sure that it works. And then we're going to go through and then take it to another level and get some water in these tanks and start doing some practical testing to determine whether or not this heating system really is going to work, because I really hope it does and I have high confidence in it. It makes perfect sense how it's going to work. We just have to give it a shot and see what happens. So thanks for watching today's video, and I will catch you on the next part of this series and next week's video. Got a lot of fun stuff coming up. Stay tuned. If you liked the video, please give me a like. If you have comments or questions, please leave them down below. And of course, if you want to see more videos on my 1600 gallon system, unboxing, DIY projects, go ahead and hit that subscribe button. You can watch a video at least once a week. So thanks for watching, and I'll see you on the next video.